Сейчас будет с докладом Internet of Machine Learning Kristoffer, Rolf, Deinoff из компании Consulting. Поприветствуйте его.
Hello, welcome to my talk, the Internet of Machine Learning, practical introduction. So this will probably be the one talk that does not contain any math today. It will be pure practical. And the reason why I made this talk is on hobby basis, I started to get into a little bit of machine learning. And I browsed the net and I found a lot of presentations, a lot of technical presentations and online studies and stuff like that. Very, very little practical information on how to actually get started and do something without like going to university to learn the basics and beat out stuff. So that's what I'm trying to cover today, and I will go through a demo. I will demonstrate how you can do this in the .NET platform with a simple, small library called Numal. So, I guess we can start. So, the basis of our analysis that we're going to use, it's training data, exercise data, fitness data. I have 4 sources for this data. That's Sports Tracker, Runkeeper, Strava, and Polar Personal Trainer. I don't know if you know about any of these. Several of these you can have apps on your mobile phone. You have physical devices, and yeah, which record heartbeat, GPS track data, and different stuff. And I wanted to try to find out what can you try to learn based on the history of this. So, of course, these data come in different formats. So I have to find what is common with these data, so I can treat them as a single entity. And by doing that, I have made a small class, an activity, which I have the average speed, the date, the distance, the duration, and the type of activity. And that's the basis of our exercise data. Then I thought, how can I do something funny with this? And I got some weather data. I have historical weather data for the entire period, and which a friend of mine, all the training data comes from a single friend of mine. And we have the weather forecast. Also from the Norwegian Meteorological Institute. So I was thinking, how can I use the weather forecast for next week to help me tell what type of exercise am I going to do, and how long should I run, how fast should I run, or cycle, or do whatever. And we have the 2 types of weather data. We have, for both of them, we have the date, the precipitation, the rain, you have the temperature and the wind. You have some other data from the historical data, but I will not use this and that in this demo. So, this is a graphical look on what data I have. It's a little bit sporadically. Some of the data sources don't have all the data. The green line is the weather data. So I have the weather data for the entire time, the period. If you see the red bars, that's data where I have both the activity type and all the other data. Black lines, I do not know which activity type it is. So I have 2 ways of, 2 data sets, training data sets, to make my analysis on the basis of. So, The next step to do when I have all my data and I merge it all into a single format is to classify the data. And this is the way I'm going to use it. This is the way that Null does it. It's a relatively simple way or a standard way of data classification and text classification with machine learning, where you have your input, that's the classes you saw, and you have a feature extractor, which tells something about which part of this data do I want to learn from, and then you also have a label, which you, let's see if I can, the label, that's the thing that you want to learn from the data set. So you have two phases. You have the training, where you supply both the input and the label, and later on you can supply the same type of data without the label and predict what the label will be. And this is the classification that I end up with. I have two types of classification. And as you see, that I've combined now the weather and the exercise data, and I have two classes. The first class is everything without the type, and the other class is with the type, and represents the two data sets that I'm going to use. And my aim is to make a decision tree. This is just a sample decision tree. You have many types of way of doing machine learning. Creating this decision tree is one of the easiest, which it doesn't require you to know a lot of math and the technicalities from machine learning. And as you see there, you have a dependent variable, and these have three states. You have the sunny, the overcast, and the rain. And it says something about if you play or don't play based on the weather. And then when you come to that step, to make a better decision, you check the humidity or the wind, and you get a better prediction on what you on the label of your data set, basically. And when we have made our decision tree, we want to learn from that data. And I've implemented a few methods for each of the classifications. That way you can see here, I have a typed activity learner, and I have an activity learner, which I can predict activity type by weather. I can predict activity type by weekday and the hour. So what kind of activity will be most likely for me to do at Tuesdays at 6 p.m. I can predict the average speed by the duration of the activity and which type it has. So what will be my average speed if I bicycle for 1 hour? What should be my average speed? And I can predict the distance by the activity type. So, yeah, if I'm going skiing, what's the suggested distance for me to go exercise? And now we can go over and actually look at some of the code. So here, we can close all. Here you will see this is probably a little too little. I'll just make my screen a little bit bigger for you. There you can see a little bit better. I have my solution. I have a library for reading the graphical files. That's not that interesting. I have my services. My services is the services I use to read the data from the data providers and create the specifications that I need. And then you have the learning part, which creates the descriptors and the learners. And I can take a look at how a classical learner would look like. So here, if I have the method for learning the activity type by the weekday and hour, I use the normal descriptor for, I say which type I want to describe, make a descriptor from, and I say with the date time, and I provide the time property, and I said that the day of the week is a part of the time that's interesting for me, and the hour with the next feature. So the two top lines here will be the features, as you saw in the slide. I can go back to it here. So the features will be the top, and the learn will be the label. And then we actually call the neural library, in which I create a new decision tree generator, and I ask the model to learn. I pass it a list of activities, and I have two numbers here. I have a training percentage. It says right now this is 0.8. That means 80% of the data I put in, I will use to learn from. I will use to make my decision tree. Then I will use 20% of that data to try to validate, to see how good is this decision tree for predicting new values. And I have a repeat count, which I say, oh, let's do this 1,000 times and give me the best decision tree with the highest percentage of hit percentage. And we pass in the generator. It's a decision tree generator. And I also save the models to disk, so you can see, so you can store them for the future. You can relearn, add more data to make the predictions better in the future when you do more exercise. So you can do this on a weekly or a daily basis, or after every time you have done exercise, to make the model better and better and better. And then you can actually use some of these things. And I will use Pad to show you some of the stuff here. So what I do here is I go to the weather service and I say get the historical metadata for Oslo for the last 3 years. And then we connect to the fitness service and we get the activities. This is now, I have the activities by average speed, so we can take a look at the data now. And first we see the non-type data. So all the types are other because the GPX file format does not support or have a standard for saying what kind of activity it is. But for two of the data sets, I also have an XML export which tells me which type of activity it is. So this is the base data from the non-typed, and here you can see the historical training data with the type. So some of them are still other. Most of these are going to the gym and lifting weights. And you have some running, you have some cycling, and skiing and walking, and different types of activity. And so this is and the next here I have the type activity descriptor, where I merge the historical weather data together with all of the activity data. And this is the descriptor. Here is just the merging of that data, and I'll make a descriptor here for with data, the hour, the day of the week, and the hour, and I will learn the type, which activity type is most likely for me to do in a given day, weekday, and a given time. And I learned this with an 80%, say 10,000 times, and I will dump the model so you can actually see the decision tree. And here you can see that decision tree, and it says that the hour of the day, it's on the top level, the hour of the day is the most important factor in my test data set. And for some hours of the day, it doesn't matter which day of the week you have. But if you can get to 9 o'clock in the morning, especially there, you do a lot of different activities based on which day. So you have for 0 is Sunday, so you have for Monday, Tuesday, and Sunday, you usually cycle at 9 o'clock. And Thursdays you walk and you go to the gym on Fridays. That's what he used to do. This has an accuracy of 77% correctness based on the historical training data that we have provided. And then I just loop through the next week, each hour from 8 to 24, and I try to predict. Which activity will be. And you can see down there that you have pretty much different activities. It varies very much what time of day. So this guy, he has a lot of running late at nights. You can see that if he, almost every day, if he runs at, trains at 10 or 11 o'clock, he runs. If he goes at 3 o'clock, he usually does a bicycle trip. So this is the first stage of our learning, to actually make a few predictions. Then we have another scenario here where I try to predict. I try to use the methods I have for prediction, and I try to combine them. As you saw in the, I can find the chart over here. Some of the methods try to predict the same thing, but they do it based on different data. So in the next step, I will try to find what is the best, the correct guess based on these three things. So I value them differently. If I get it from the typed activity learner, I will value that information more than if I get it from the non-typed activity learner. And I will try to see if that can help me. So I get the first distance predicted by the weekday, then I predict the distance by the weather. And here, for the distance, I just add them up and divide them by 2, so I just take the average of that. After testing a little bit, back and forth, that formula gave the most reasonable outcome based on the other historical data. This is part of supervised learning, where you don't just give all your data to the machine learning algorithm and let it figure it all out for you, but you need to get feedback all the way to adjust your algorithms and how much weight the different factors should have to actually get useful data. So you have to help the machine learning process. And here you can see some of the decision trees made by the learners. And you can see that the distance by weekday, even though it has some predictions, it has an accuracy of 0%. So based on the data that I had, it did not, was not able to give correct predictions any times. So this prediction is not a very good one. You see also the distance by weather. The distance data is too closely connected to what type of activity. So this doesn't give you any value either. But you have here activity type by weather. It's a lot better prediction. You have, if the temperature is from -13 to +4 degrees, is less than 3 meters per second, then you will either do skiing or go to the gym. But that depends on if it's the precipitation. When the weather is cold, the precipitation will be snow and not rain. So if the precipitation is low, then you will go skiing. And if it's very much snow or raining, he will go to the gym. If there's not, if there's too much wind, then he suddenly, weirdly enough, he will go skiing. He likes to go skiing when it's a lot of wind. But if it's a high temperature, then he will go cycling. And this is a prediction rate of 74%. And you have the activity type by weekday and hour. That was the one we just saw. You have also the distance by activity type. And here it's also not very good because he doesn't have a very uniform distance. He doesn't cycle the same distance every time he cycles. He doesn't run the same distance. So it's hard to predict what will be the correct distance. And you will try to merge this data down. And we can try to do this with, put it into some other formats. I can go here. This is some of the data that we want to create. We want to create a calendar for the next 9 days. To say which type of activity do we want to go. So this is for Oslo and for Kharkiv. I've used the forecast data for Oslo and for Kharkiv. And you can see that the weather data is there, the amount of degrees, precipitation, and the wind. And you can see that based on the weather, in Oslo, he would go cycling all week. In Kharkiv, it's too cold, so we'll go skiing. This is actually how I found out that I needed to bring more clothes here, because it was so cold. And you can also say at Kharkiv, we're missing one day of forecasts from the data set, so we are not able to do any predictions there. And we combine this data with what kind of activity per hour you want to use, and you get a little bit different calendar. If you see over here, you have the date, and you have, you can see it better from this. You have the date, and you have grouped the different types of activities, and what distance and what speed it should go at, and what times of day is best for doing that activity. So if you want to go cycling, then you should, 30th of October in Norway, you should do that at 8, 10 or 11 o'clock in early at the day, or you shouldn't wait till 3 o'clock or 7 o'clock. That's the best times for you, or for him, my friend Bruno. And you can also see the same with walking and the speed. And there's also possible to create other types of classifications. So if we can try to do a new prediction live here, and we will just find our descriptor and see if there's any new things we want to learn. And we can see here that we can try to predict some of the temperature, for instance. So if we take the date and the temperature and wind, then we can try to predict what will be the rain. Okay, that's probably not the best thing to predict, but it's possible. It's doable. So let's go back to our link pad, and we can create. Where did it go? We can use the same here. Oh, this one was it. Yes, this here. So if we take the width time, we can take the same day, week, and hour, and we can try to learn the precipitation. We want to learn width, activity. We have to use the temperature. We want to use the wind. And let's try to do this. This, and we want to model, predict, and we will give it a new classification. So we have a new type activity descriptor. So we say that we have the time is now. Daytime now. Then go and say that the wind is equals the line of wind 5 meters per second, and temperature is minus 5 degrees. Is there anything more? Yeah, that's okay. And the result of that one should be down this to see what that result will be. To see if we are able to actually predict the precipitation or the amount of rain that will come in Oslo today. Yeah, I used Oslo. Could change that to Kharkiv though. No, that's only the Oslo. And this will run for a little bit because it needs to get all weather data.
May I ask a question?
Yeah, sure.
You have written all stuff in .NET. Is it does .NET have mature machine learning library, or you write all algorithms by yourself?
No. Right now I use a library called Numo. It gives you, it's a very easy to use supervised learning. It's supervised learning, but it has different types of, let me see if I can find the types of generators. They have a lot more advanced generators, so you can do some naive Bayes generation and let's see.
Okay, I understand. May I ask one more question?
Yeah.
You have built a model, but you didn't describe how you select this model. What pre-selection steps to select the best model?
To select the best model when after learning?
Yeah.
Well, that's the thing about that grammar. I say that I will do this, run the generator 1,000 times, and the library will automatically pick the model, the best model from that.
Okay.
From my library. So the normal library is very easy to use. Just if you have some data that you want to do machine learning and analyze on, it's very easy to just get started and use it. And I can also go a little bit through how I created these charts and how I merged all that data together. And so I made myself an exercise planner here. So what the exercise planner do is ask me to create an exercise plan for a place that's for Oslo or Kharkiv or any other place that the weather site EU.no gives weather forecasts from. And I create my learner factory, and I get my learner and type learner. And I go through, I get the forecast for next week, and for each day, as I said, I get the distance just by averaging the distance predicted by weekday and by weather. I also get the duration by weekday and weather. There I add them and divide them by 1.5. 1.5 was the best number, or the number that gave the most accurate prediction or combination. That was a trial and error. The numbers I've used here is trial and error. Then I try to predict the activity type by weather, and I try to make these hourly exercise plans. The hourly exercise plans will basically go through, and first it will try to predict the activity type by weekday and hour, and then it will try to predict the distance by the activity type we just predicted before. So here I will use the results from one of the predictions, and I will use that to try to predict another variable. So, and I will do this in several steps. So instead of just using, we get a more advanced prediction from that and more related. And I have just made a formula for calculating the distance. I found that the distance based on type would be 80%, and I will just add the bad distance, because that distance was the 0% model. So it was a very, very bad model, but I wanted to join and give it a little bit of value anyways, and add it. And then I tried to predict the average speed by the duration and the type that I have already, also the activity type that I predicted over here, and the duration that I predicted and over here. And that's how you will get to these the calendar predictions. Let's see if I can show you a little bit bigger here. So, do you have any related questions to what I just said? Yeah?
Yes, we do. So, basically, you're trying to infer from the previous data what the types of activities are going to exercise.
Yeah.
Right? Now, my question is, what is the value of this whole thing as far as, like, if you're trying to predict something?
Yeah.
I'm saying you should maximize some sort of, I don't know, feature or like power outcome. If you do cycling, you should basically use cadence and that kind of attributes, that kind of features. So with this type of prediction, what are you trying to maximize?
With this type of predictions, the logical next step here would be to add a small increase over time. So I will try to exercise a little bit more every time. So I will have a gradual increase in how long, how fast, and everything. So I'll choose a percentage that every month I want to increase by 10%. And I will add this into the model and the prediction model there. Also, when you then register your new activities, you can compare it, use the models and compare what was predicted and what was actual workout. If you did more workout than predicted, then you could get a star, or you can get a bonus, or the business case this is taken from. It's you will get some badges or and something to motivate you to actually to do that exercise, and to exercise more and longer and more often.
Your question related to the error of the model. You you do multi-categorical prediction, and my question: what is the error of prediction? How you define the error? And what is the accuracy of your model?
The accuracy of this model is sadly not that great, and we come back to, if you see the models here, some of the models, because of my data set, is not that big. Since it's personal data, I couldn't just take 100,000 persons' personal training data and use it for my own purpose. So I got this from a friend of mine. So I don't have enough data points to do really, really accurate predictions. But if I'm going to use this in a business case or in a real case, I would first try to generate my models, and I would only save the models that have a relatively high accuracy, and I will use the influence a given model gives to the end value will be based on the accuracy the model itself gives.
You didn't answer my question. I asked how you define this error? How you check calculate the error of prediction?
Well, right now I do not calculate the error at this moment.
You don't calculate the error of your prediction.
No.
Yes?
I don't do that right now, but that's a part of the accuracy you get here from after learning. It's the new library's evaluation of that model, of the error rate of that model. Because when I do a learning, I specify percentage of my data model that would be used for the training, and percentage that's used for evaluating my model and finding out how accurate it is and how big the errors are. Does that answer your question a little bit better? Or?
Not really.
Okay, we can maybe take that later if you come to me. I can try to answer it better.
Hello.
Yeah.
My question is about your features. You have listed the features you have used in your learning, but did you try during your investigations to add some more features or remove existing to increase your accuracy? Like, let's say, if there is snow outside or not only rain, but seasonality or even month name or something like that.
I tried a little bit. That's how I ended up with saying that the activity per weekday was not that good, or activity by weather was not that good. So I tried to combine it with the weekday and the hour, for instance. And I've done a little bit of that and playing around with what we will define as features and what you will define as labels. That's a part of the supervised learning process. You will use your input and your know-how of the data, and you will make a model and see how, and then we'll try out, see how well that fits with what you expected. And if it doesn't fit at all or doesn't fit good enough, then you shouldn't use that. So if I had used this demo in a real setting, I would remove all the models that give me zero accuracy. I will make new models which have tested accuracy, and I will probably add some more training data or wash the input data a little bit more, so it's easier to analyze. For instance, I realized that if you don't have the activity type, a lot of the predictions doesn't work very well. So that's needs some more specification of the input data to make better predictions in this case. Yeah.
I would like to ask you a question about, you told us that you generate, for example, 1,000 models and choose the best from them.
Yeah.
The question is actually, what's the measure of what their model is best? Am I right that, as I understood, you reduce your learning sample, you take a subset of your learning sample, make a prediction of excluded elements of the subset and compare your forecast. Yeah.
So the parameter I provide data, and so I made myself an exercise planner here. So what the exercise planner do, it's asked me to create an exercise plan for a place that's for Oslo or Kharkiv or any other place that the weather site yr.no gives weather forecasts from. And I create my learner factory, and I get my learner and type learner. And I go through, I get the forecast for next week, and for each day, as I said, I get the distance just by averaging the distance predicted by weekday and by weather. I also get the duration by weekday and weather. And there I add them and divide them by 1.5. 1.5 was the best number, or the number that gave the most accurate prediction or combination. That was a trial and error. The numbers I've used here is trial and error. Then I try to predict the activity type by weather, and I try to make these hourly exercise plans. The hourly exercise plans will basically go through, and first it will try to predict the activity type by weekday and hour, and then it will try to predict the distance by the activity type we just predicted before. So here I will use the results from one of the predictions, and I will use that to try to predict another variable. So, and I will do this in several steps. So instead of just using, we get a more advanced prediction from that and more related. And I have just made a formula for calculating the distance. I found that the distance based on type would be 80%, and I will just add the bad distance, because that distance was the 0% model. So it was a very, very bad model, but I wanted to join and give it a little bit of value anyways, and add it. And then I try to predict the average speed by the duration and the type that I have already, also the activity type that I predicted over here, and the duration that I predicted and over here. And that's how you will get to these the calendar predictions. Let's see if I can show you a little bit bigger here. So, do you have any related questions to what you just said? Yeah?
Yes, we do. So, basically, you're trying to infer from the previous data what the types of activities are going to exercise.
Yeah.
Right? Now, my question is, what is the value of this whole thing as far as, like, if you're trying to predict something?
Yeah.
I'm understanding you should maximize some sort of, I don't know, feature or like power outcome. If you do cycling, you should basically use cadence and that kind of attributes, that kind of features. So with this type of prediction, what are you trying to maximize?
With this type of predictions, the logical next step here would be to add a small increase over time. So I will try to exercise a little bit more every time. So I will have a gradual increase in how long, how fast, and everything. So I'll choose a percentage that every month I want to increase by 10%. And I will add this into the model and the prediction model there. Also, when you then register your new activities, you can compare it, use the models and compare what was predicted and what was actual workout. If you did more workout than predicted, then you could get a star, or you can get a bonus, or the business case this is taken from. It's you will get some badges or and something to motivate you to actually to do that exercise, and to exercise more and longer and more often.
Your question related to the error of the model. You you do multi-categorical prediction, and my question: what is the error of prediction? How you define the error? And what is the accuracy of your model?
The accuracy of this model is sadly not that great. And we come back to, if you see the models here, some of the models, because of my data set, is not that big. Since it's personal data, I couldn't just take 100,000 persons' personal training data and use it for my own purpose. So I got this from a friend of mine. So I don't have enough data points to do really, really accurate predictions. But if I'm going to use this in a business case or in a real case, I would first try to generate my models, and I would only save the models that have a relatively high accuracy, and I will use the influence a given model gives to the end value will be based on the accuracy the model itself gives.
You didn't answer my question. I asked how you define this error? How you check, calculate the error of prediction?
Well, right now I do not calculate the error at this moment.
You don't calculate the error of your prediction.
No.
Yes?
I don't do that right now, but that's a part of the accuracy you get here from after learning. It's the neural library's evaluation of that model, of the error rate of that model. Because when I do a learning, I specify percentage of my data model that would be used for the training, and percentage that's used for evaluating my model and finding out how accurate it is and how big the errors are. Does that answer your question a little bit better, or
not really?
Okay, we can maybe take that later if you come to me. I can try to answer it better.
Oh,
yeah.
My question is about your features. You have listed the features you have used in your learning, but did you try during your investigations to add some more features or remove existing to increase your accuracy? Like, let's say, if there is snow outside or not only rain, but seasonality or even month name or something like that.
I tried a little bit. That's how I ended up with saying that the activity per weekday was not that good, or activity by weather was not that good, so I tried to combine it with the weekday and the hour, for instance, and I've done a little bit of that, and playing around with what we will define as features and what you will define as labels. That's a part of the supervised learning process. You will use your input and your know-how of the data, and you will make a model and see how, and then we'll try out, see how well that fits with what you expected. And if it doesn't fit at all or doesn't fit good enough, then you shouldn't use that. So if I had used this demo in a real setting, I would remove all the models that give me zero accuracy. I will make new models which have tested accuracy, and I will probably add some more training data or wash the input data a little bit more, so it's easier to analyze. For instance, I realized that if you don't have the activity type, a lot of the predictions doesn't work very well. So that's needs some more specification of the input data to make better predictions in this case. Yeah.
I would like to ask you a question about, you told us that you generate, for example, 1,000 models and choose the best from them.
Yeah.
The question is actually, what's the measure of what their model is best? Am I right that, as I understood, you reduce your learning sample, you take a subset of your learning sample, make a prediction of excluded elements of the subset and compare your forecast. Yeah, okay.
So the parameter I provide my learning here, the 0.8, which I'm using in the learning base here. The training percentage, that says if that's 0.8, then it will use 80%, randomly 80% of the data, and use that for learning, and just as random the next 20% to try to predict and see how well the prediction fits with the other data. So we use that to evaluate.
Gosh, I just wanted to point out I asked precisely the same question in another talk about time series forecasting, and I got precisely the same answer. So
yeah, that's something that NUML does for you that you don't have to do. If you're going to write all the code by yourself and not use an external library, that's something you absolutely have to take into consideration to evaluate the models. But yeah. NUML gives you the accuracy of the model, but it doesn't give you like the error rate.
Thanks. And you told about training data set percentage, 80% regarding training and 20% for validation. So how did you distinguish these values? I mean percentages.
How I came to 80%? Well, I used the same percentage that was used in the demo for how to create a simple prediction in NUML. And I've actually tried around with some different values, but for this demo case, I just used the 80%. That's what I have been using when I've made some other demos manually as well, 80-20.
So it's the best option which gives them the most optimal value for
I don't know if it's the best option. I think that should rely on a little bit on what data you have and how much data you have.
Thank you.
Hi, why did you choose weather like a weight coefficient in your learning system? Because I think it's better to use some physical measurement like blood pressure or heartbeat, and I think exists a lot of kind of sport where we do that inside the building, like in gym, like swimming in pool, and it's not connected with weather.
No, and for some of the data sources that we had, for some of the data sources, you do have the heartbeat. For the polar, you have the heartbeats, heartbeat monitor. You have some other data. The reason why I chose to narrow it down was because that was the data I had in all 4 data sets. And each data set was not big enough to actually give some predictions. So even though it's 3 years of training data, he's not the most active person, so it's a relatively small subset. And absolutely, what you want to learn and what will be your labels and features, it should be different than what I've demonstrated. My demo is more like, this is how you can do it, and this is how you can do it in different ways, and not, this is the way you should do it. Just to show how simple it can be to make some relatively advanced analysis without having a lot of prior knowledge to machine learning. This is something that anybody with even a limited programming experience can go home and do tonight in the easiest part. So you don't need to be a machine learning specialist to use machine learning. basically one of the main ones. Even though that certainly does help you to give more accurate models and better predictions, I would never make a stock market robots this way. Then I would certainly hire some expertise in that area to make models more correct. But there's still valuable information you can get from doing this simple form of machine learning. Any more questions or comments?
Could you please make this code templates shared with
Yeah,
all
sure.
of us? Maybe not with your personal data, but only just code which we can play with.
Yeah, absolutely. It's available. I need to do a last check-in, but if you go to github.com/gateweb, there you have, please don't look at most of these repositories because that's just stuff I've been playing with for several years and it's bad code. Here it's actually also another machine learning example that I created a stock trading, super simple stock trading wallet from scratch without using machine learning library. But here, the itera.machinelearning.fitness is the code that I've been showing today. And that also includes the code for a couple of these link pad pieces of code that I have been demonstrating. So I will, later today, I will do the last check-in so you will have everything available. And if it's interesting for you, you could also do, I also made this other machine learning stuff, and that's just to show how you can do some machine learning without using a machine learning library, just from scratch. And this will basically try to find patterns in history of stock tickers and try to evaluate those patterns based on how many matches, the percentage it gives, and the spread. And just a simple, fun thing. More questions or comments? No? It's time for lunch, huh?
Давайте поблагодарим Кристофера. Спасибо большое. Друзья, у нас сейчас часовой перерыв на обед. Вы можете выйти в город, тут есть недалеко Макдональдс. У нас тоже есть компания «Ресторанный день», можно там у них приобрести еду. Через час мы здесь встречаемся и